Hereby I'm now giving the pre-prac for experiment 1 and 2. So in experiment 1 we will be looking at vanadium. On the screen you are looking at the modified power bar diagram. Now a power bar diagram is very useful to tell you which vanadium species do you have in your solution. So this speciation is dependent on the pH and the concentration. So if you look at this graph, you can see you've got a lot of different vanadium species here. So depending on the pH and depending on the concentration, you will have different species. So on the x-axis you have pH, on the y-axis you have log molality. Molality is a concentration term and you have dealt with that in physical chemistry too. So now, for instance, if you are sitting at a pH of 2 and a log molality of -5, then you have VO2 plus as your species. For the same concentration of log molality of -5, if you increase the pH, say to a pH of 10, your speciation will be changing from VO2 plus to VO3 OH to the power -2. So your species changes when you change your pH. Now, for example, you are also changing the concentration. If you are increasing the concentration from log -5 to log, say, -1, so we are sitting at pH 10, but we are changing from -5 to -5 -1 for the concentration. So your speciation will change from VO3 OH to minus to V2O74 minus. So you can see the speciation changes when the concentration changes. So in the Y direction, the concentration changes and therefore your speciation changes. In the X direction, your concentration is constant but your pH is changing. So in the experiment, you will be making different concentrations. You'll be calculating the log molality and you will have an estimate for your pH. So using those two numbers, you will then see where are you on the graph. So if you are, for instance, at a pH of 6 and a concentration of -5, then you know your speciation is VO2 OH2 minus. So depending on where you are in terms of your pH and your concentration, you will find your point on this graph and you will know which speciation you have. Just a reminder of some basic chemistry which you should be familiar with from chemistry 1. If you've got magnesium fluoride and you've got 1 mole of this compound, how much moles of magnesium do you have? So you've got 1 mole of magnesium fluoride, how much moles of magnesium do you have? So in this complex, you can see there's just 1 magnesium. So therefore, you have 1 mole of magnesium. But now, if this magnesium fluoride dissociate, you will find that 2 fluoride ions will form. So how much moles of fluoride do you have? You see there's a subscript 2, so which means if you've got 1 mole of magnesium fluoride, you have 2 moles of fluoride ions. Let's look at sodium sulfate. If you've got 1 mole of sodium sulfate, you will have 2 moles of sodium in this compound, because you see there's a subscript 2, which means you've got 2 moles of sodium in sodium sulfate, and this sulfate ion will stay together when it dissociates, and you will have 1 mole of sulfate for 1 mole of sodium sulfate. Now in your experiment 1, you will be using V2O5. It's vanadium pentoxide, which means you have to calculate the moles of vanadium, because remember now, over here you have the log molality of vanadium, not V2 but vanadium. So over here you are dissolving V2O5, but you want to know the moles of vanadium, not V2, vanadium, which means for this compound you have 2 vanadium. So 1 mole of V2O5 will give you 2 moles of vanadium, because there's a subscript 2. So please remember to take this into account in your calculations. Okay, modality is a term that you should be familiar with, and we have dealt with that in physical chemistry too. So please consult McMurray and Fay if you have forgotten how it works. Molality is a mole of solutes per kilogram of solvent. In this case, you have water as solvent. But take note, the units are kilogram. You will be using milliliters, which you have to take to grams, which you then have to convert to kilograms. It's moles of solute per kilogram of solvent. So you will have moles of vanadium per kilogram of water. Then after you've calculated the molality, you need to take the log of your molality, and the answer will be negative. So if you get a negative answer, it's correct. If you get a positive answer, you have made a mistake. So then you have to recalculate and check. In experiment 1, you will have to calculate the oxidation number. This is an example to calculate the oxidation number of V2O7 to the power minus 4. So now your vanadium is a transition metal and it can have various oxidation states. So now you have 2 vanadiums in this species. So therefore you have 2x, you have 7 oxygens. It's not a peroxide, so therefore the oxygen's got an oxidation state of minus 2. So 7 times minus 2, and this whole compound has got a charge of minus 4, so therefore it's equal to minus 4. Now you can solve for x. So when you solve for x is equal to 5, which means your oxidation state of vanadium is 5. This table gives you a correlation between the oxidation state and the color. So here you have VO3 minus, and it's got an oxidation state of 5 and it's yellow. Here you have VO2 plus, it's got an oxidation state of 4 and it's blue. Here you've got an oxidation state of 3 plus for your vanadium and it's green. And here you've got vanadium 2 plus, oxidation state of plus 2, and the color is lavender. You will be using V2O5 and you will be adding a zinc that will be reducing your vanadium, and as you add your zinc you'll see different colors. So depending on the color, it will give you a particular oxidation state. We will also be looking at chrome. So if you've got chrome with oxidation state of plus 6, it's yellow or orange depending on the pH. If you've got oxidation state of 3, it will be green, and if you've got an oxidation state of 2, it will be blue. So we will be adding zinc to chrome and it will turn blue, and then we will expose it to air and it will be oxidized in air and it will return to green. Please make sure that you are filling in the test on Blackboard. If you have had problems logging into Blackboard or accessing anything, please come and consult me. I'm Dr. Phil Yun in J201.